and it's Andrew Clay Schaefer. Got a late night chat with Waters James, who I'll let introduce himself.
Yeah, all the way from the glamorous Weston, Minneapolis, here in Minnesota. Um,
I'm down here in my basement with the treadmill. As
all,
one,
all the way from Pittsburgh.
yeah, Pittsburgh, live from Pittsburgh. So we've talked quite a few times at this point. The first time we met was in OSCON 2010. We just sort of hit it off, had many discussions about many topics, but you're working on something pretty interesting. At least some people think it's interesting, and maybe you can kind of talk about that for a second, and then we'll segue into some of the stuff we tend to talk about.
Yeah, thanks, Andrew. So I work at this company, Pivotal. Andrew is one of the people that keeps me humble, keeps me smart. Talked to him many times, usually not recorded, but sometimes we go crazy. Um, and we got this crazy idea at Pivotal that maybe infrastructure isn't the end, and maybe you could start consuming things that are centered around applications and data, and that might be where the next level is all waiting for us down the line. And I spend a lot of my time right now, you'll see me now in glamorous hotel rooms throughout the United States, going to talk to enterprise people about upping the game a little bit from just counting VMs to saying, hey, how about an application or a platform?
So let's kind of define some terms. When you say platform, what does that mean to you right now?
Yeah, I literally had the I literally had one of the head consultants to one of the largest top couple financial institutions in the world corner me once and say, hey, what's the difference between this infrastructure service layer and this other stuff above it? And I said, well, somewhere in any system you have, there's a database entry or an entity somewhere that's describing something that it's controlling. And in a infrastructure service, the entry you'll see describes a virtual machine, it describes networks, it describes disks. And I said, where do you have a system that keeps track in a highly engineered and tuned way where your application lives, where your domains live, where your app health is, where your latency is, where all the things that you would describe as an application, where does your system keep that? And it turns out that a lot of people keep that in things that you wouldn't describe today as a platform. They're more sort of left to the user or left to a scripting environment or configuration management, and they're not really a platform or a system. And so when you go deep and you study how Netflix or Google or others would solve this problem, they wouldn't say, okay, well, we'll do automated things to get the virtual machine and then meat space it after that. And I think that's what most people don't realize is they don't really have a system that has entities in it that say things like applications and domains and etc.
So I'd say watching this evolve, and I think there's kind of a confluence of these other DevOps conversations and the continuous delivery conversations. When I look at what some people have done, there's definitely things that are kind of meeting that level of definition of platform that people have built, and that they can deploy, and they have a system that has an idea around those kind of services. With whatever, even back before there was the kind of proliferation of configuration management that the DevOps conversation kind of got centered around, people were building those systems with scripts, but they all had one-off, specialized versions for their little snowflake.
Yeah, and I think that's why it's an evolutionary pattern. It's not that people didn't have this problem before; they just hadn't solved it as a systematic way. So just give you one example that comes up a lot is, say, load balancer configuration. So if you want to do normal automation, you might log into your F5 load balancer with a script that you've written and tell it to do things, and you hope that it does those things. But when you actually want to ask the system what is the exact state that I'm in and change it very quickly, a lot of those cogs don't turn together as neatly because they weren't created or honed to do so. So in our system, it happens in microseconds, the change of configuration of our routing tier between different applications and the traffic that's forwarded to them, because they're all designed to, to change very rapidly together. Versus, if you talk to someone even like an eBay, in our conversations with them, it takes them about 30 minutes to push an update to their system all in and to change the HTTP forwarding. And in our system, you can push an update and change that in about 20 seconds, or as long as it takes to start a Java app.
So what's actually happening in the 20 seconds or whatever the time is? What's the difference between whatever you're comparing it to and what your platform does right now?
Yeah, I think the difference is that the entire system was built end to end to do the 30 or 40 things that you want to do with the life cycle of your app, and every component was created to do that. And so when an application starts in the Cloud Foundry context, it'll message out across the message bus, "Hey, I'm alive. Here's where you can find me." And instead of going to a generic listener, which will kick off a script to reconfigure an HA proxy or to reconfigure an F5 load balancer, we've actually built our own custom routing tier into the platform that listens, and in, again, microseconds, we'll go, "Oh, that's where that app lives. I'll change my forwarding table." And so everything was built completely to accomplish that goal. And it's a classic engineering principle that, sometimes it's better to build a tool specific to what you're doing versus using, general purpose things.
So then, in some sense, it's not apples to apples because you're doing different things, but those different things are very similar in the sense that you wrote your own router instead of going through, whatever HA proxy or F5s or Netscalers or whatever you're going to use. And I think just kind of watching like that capability, do you think there'll be any attempt by those kind of vendors to make their systems be more capable of these kind of, like, if you're driving things by a timescale question, wouldn't it make sense that I could do API-driven configuration of those types of things in the next generation of them?
Yeah, I think you can always write code to do whatever you want. I think the question comes down to, do you want to take advantage of code that has a lot of mileage on it to do that task? And in our case, we're trying to build a pretty large open source ecosystem with hundreds of thousands to millions of applications always running on this thing, and other people giving us a feedback loop, and etc. So you start to have to ask yourself, okay, do we want to add value at that layer, or do we want to say, okay, great, you've done that for us, now we're gonna move up from there.
So let's assume, let's kind of get off this question of like how fast things are, but like, what is the actual thing that people can do with the platform today that they're either wanting to, they can't do, or that's more efficient to do with this sort of standard platform?
Yeah, you know what? Like when I talk to folks, I like that I don't use this a lot.
You're freezing.
He's got like a camcorder, and he's got a Walkman, and he's got like a voice recorder, and he's got headphones. He's got 50 things that he could do all the things that your iPhone does. And then they show like 2013, and they're like, "Yep, it does all of those things there for you, and you've now moved on with your life. You can take that anywhere." I think to some extent, a little bit of the, you might call it Luddite reaction to platforms is, well, I can do all those things today. And you have to see that having one system that's designed to do those all and to relate those all together so that your app deployment and then your app update logic is all connected, and it's connected to app health management, it's connected to app log aggregation, and then it's connected to app binding to services. The whole system was designed to work as one, as opposed to designing that again and again and again from scratch. So maybe that doesn't answer your question, but it's a metaphor.
No, I mean, I think we're getting into interesting territory. So when you have this platform that's doing these deployments of these runtimes, those runtimes weren't built with that platform in mind per se. Don't you ever have like kind of an impedance mismatch between, or do you notice in the development cycles whether you're deploying, Java versus Ruby versus PHP versus I don't know the full list of what is supported right now, but doesn't that
Pretty much anything on Linux that has any metadata. I mean, you can run things like C binaries, but it's pretty boring.
sure but I guess what I'm saying there is, if the argument is that like these are this kind of, if the whole thing is designed as this unified kind of iPhone analogy, then those runtimes, they weren't designed that way, right? So do they have in between them, they might have their own kind of different
No,
peculiarities?
I disagree with you, Andrew. I actually think it's much more exactly like the iPhone paradigm because the iPhone was designed to have this context of an app, and that app has various services it can bind to. It's like, oh, I can grab camera, I can grab gyroscope, I can grab all these built-in things, but you can still put whatever custom logic you want in that app context, and
Well,
that's
as long as you're willing to write it in the things that are supported on that platform.
yeah, and we're more general purpose, of course, than an iPhone.
Well, I guess the point I was saying is, don't you think there's another evolution where, like, the actual fabric of the runtimes could be at this next level? Like, you're basically stitching together the disparate pieces to support the Ruby Rails stuff and the I think you guys have Node and PHP or whatever.
Yeah,
Uh,
anything on Linux.
but any of those like Linux runtimes, I mean, I guess what I'm trying to get at, or like thrown out there just to have a discussion about is like there is a system, one that comes to my mind that has some of this stuff built into the runtime, and that's
I
Erlang.
was gonna say, are you gonna go Erlang? Are you gonna play the Erlang card?
I'm going Erlang because it's
That's fair.
so I'm just trying to get like a sense of how you guys are thinking about how it all kind of fits together and how it evolves, because in some ways, this actually changed the way I think a lot about systems. It's a talk from Joe Armstrong that I can't remember where he gave it off the top of my head. We could look it up. It's called the 6 Laws of Reliable Systems, or Systems That Never Stop, or something. And he talks about he talks about it in a very generic way that's non-Erlang specific, but then makes the case that this was built into the Erlang runtime from the beginning. And that's kind of like, if you want to build systems that never stop, you kind of have to adhere to those laws, and you either have to build those in at the runtime level, or you have to build the scaffolding around whatever runtimes you're going to support to kind of get the rest of those features. And I've used that list of this 6 laws of reliability or whatever in a number of presentations, and definitely just thinking about that talk changed the way that I think about trying to build systems that scale and are maintainable and operable.
Yeah, I think that's a tough question. I think when the original platform as a service vision came out from Google App Engine, there was the idea that you should limit some of the things that the runtime could do, or somehow start to have a custom SDK for the platform, right? And that was the conventional wisdom from Google at the time. And I think what we've done with our platform is we've kind of gone a little bit meta to just the runtime implementation. We say, look, at the end of the day, you're probably building something that's going to eventually return a result to an HTTP request, like somewhere along the line. And that is, in some sense, common to all of the runtimes that you can imagine, or to most of them. And so we've said, how do we build an engine that does scale-out HTTP-oriented applications, and you can use whatever logic you want behind that. But how do we make that pattern dead simple? Because that's certainly become a backbone of the internet between REST APIs and mobile backend, and HTTP has done a pretty good job. It's not everything, but it's a big start. And that's sort of the launching point for us. And I think that it was right to constrain. You have to pick at the point you want to constrain to build a platform, or else it just does everything. And we started off by constraining around that kind of scale-out HTTP app as our pattern versus any specific runtime.
So in the context of deploying these apps right now, what kind of logging, or how do you plug it into whatever other infrastructure people have to do the operations and alerting that they would to keep the farm rolling, keep the horses and the cows in the right pens?
Yeah, I think that's where the iPhone analogy comes in. Okay, you got your app, it was easy to deploy it. dead simple to deploy it and to start getting traffic into it. Then we've also given you the benefit of containerizing it, so we use Linux containers and we only use exactly the amount of memory that you need. And we dynamically manage the allocation across hundreds of physical or virtual machines where those containers should reside for the app. And we'll partition those containers into availability zones. And then every container will have a log agent which will aggregate standard error, standard out logs from the application back to a single TCP port you can pick to point it at to send it to Splunk or something like that, or Logstash. Kibana will also aggregate in the routing tier and all of the traffic of managing the app. So again, once you deploy that, you get easy deployment, easy dynamic routing, easy logging. We're also making sure that the process ID is alive, it's responding on a port, health management for you, etc. I think that gets into that, it's really about the life cycle. If it's really wrong to think of this as just developer enablement, it comes down to a lot of like, okay, how do you predictably and reliably operate these things for the next 5 years in production once you got them there?
And so right now, this is always a question, and people ask how to do different things, but I'm curious how you guys handle like the live upgrade of a running app. And so, like, say you have whatever your favorite runtime is, and then you want to do the next deployment. What's that process like on the platform right now? And what you made comments before about how fast things are. So what's that look like right now for you guys?
Yeah, that's an area where we've paid a lot of attention to a high degree of determinism, and we're always pushing that harder so that when you fire off a bind or unbind request, essentially you can have multiple apps running in the system. You can bind or unbind them to different domains or URLs that you want to forward the traffic from or to. And so you have version 1 that's running, you upload version 2 and it's live. And you can either switch over with that command a percentage of the traffic. Say you got 8 instances running and you're going to add the 9th instance and also attach it, but that's version 2. You can then blend the traffic, or you could just do a wholesale cutover 8 to 8, and in about 30 seconds you've switched over all the traffic between the two or less. And it should get shorter and shorter and shorter over time as we evolve.
I know you also have some built-in. This is something that people are definitely doing in their own kind of homegrown platforms, but the canary idea where you do rollouts and then kind of qualify, do like some sort of health check, whatever, and then make decisions based on that. So can you give us a little bit of an idea of how that's working right now?
Yeah, that's actually when you update the system itself. So when you update the system itself, we use a tool within CF called Bosch, and the guys that wrote this, Vadim Spivak, who's came from Google, who was a great engineer there. They used this tool called Borg, which was really inspired Bosch. And if you look at the stuff that Adrian Cockcroft talks about with Netflix, the two things you'll see that are important for updating large-scale systems are canaries, as well as settings for speed of update or max in flight. And so when you update the system itself, it'll try every node, every new job, as it's called, make sure it comes up before it applies it to everything else. So it's a health check that happens during the update.
So you don't get that on the apps that you deploy into the platform. You only get that on the deployment of the platform. Is that what that means, or?
Well, we could really. I've thought about this. We could trivially add that, because when you do an update to the app, when you push the app, it'll tell you if it's live, if it's up, and you can send traffic to it and see. So today that level is still more human intervention. When we do. We have a site called Spring.io, where all of our Spring developers, about 3 million a month, come, and we run that on the platform, our hosted edition, Pivotal Web Service, and there's a blog about it. And they've actually fully scripted the update to make sure that they can do the zero downtime deploys as new versions hit continuously and apply the updates live. And so in that case, I guess you're right, we could do a health check, but as part of the script, the app will only come up and say, yes, it's running and healthy, it'll naturally do that. So every time you push an app, it'll essentially give you a canary feedback of, yeah, it worked or it didn't, before you say, okay, now switch it over. So it works slightly differently at the two levels of the system. Because in the other level, you're literally saying, okay, I'm going to go update 700 different types of things, and I don't want to know about it, just go. And here there's still a little bit more like, a little bit of oversight that's happening, but could easily change. Make sense?
I think so. I mean, it's not. I haven't been playing with it firsthand, so it'd be something you figure out pretty fast if you're. So like, say you have a fairly big app that's running your system. Would you recommend, like, what manner of doing an update to the live site or whatever, if you will? If I had, I know at least from the last year, it seemed like there were some, especially in Asia, some bigger companies that were running platform. The traffic that they generate and the kind of stuff, I can't imagine they're just like switching the whole thing over wholesale in one go. So I was just curious what people are doing.
Yeah, I mean, there's Baidu and Jingdong and a number of massive companies in China that have been using the platform open source and doing some amazing things with it. And what they're doing is they're scripting against our API to exactly like I talked about with the Spring site. And so they can script that API. And one thing I talk about with customers, there's always going to be a little bit of custom orchestration and scripting that happens no matter what you do. But what you're trying to do is you're trying to make that as simple and brain dead as possible and really raise the waterline of what that script is responsible for. And so in this case, it's like, okay, apply update. Did that come up? Okay, it came up. Now start switching traffic over. It's not hard. Like, it's just a couple of quick commands to do that.
This is something that actually came up. I had a bit of a conversation the Friday because we were doing the DevOps Days Pittsburgh, and people started asking questions about doing these kind of deployments where you have to change the databases. Like,
yeah.
So if you have something that relies on a new schema, then how do you handle that kind of deployment, or what's the special sort of sauce hand-holding that you need to do to do that well? And I think by context, there's a few tricks you can do to minimize the impact and have some sort of way to reliably roll back. But in general, the data layers tend to be a little harder to update than the app layer. So I was wondering what kind of things you've seen in your projects or the way that people are using your stuff are doing that.
Yeah, I mean, I think our first ambition was to make the app layer just brain dead simple to update within 20 seconds and easy to cut over on command. And we haven't gotten into some of the hard problems around schema update and rollback and controlling that via an API and the database, etc. So I think that's a frontier for us to take on. But we do eat our own dog food. We're updating the Spring.io site. Once a day, we're updating our own Pivotal network that runs a lot of our customer interactions. Frequently, we do agile development and continuous delivery on them. So the scripts get more complicated when you have schema involved, but by and large, it's taken a lot of the burden off of having any ops team. And the cool thing is that literally the team that's developing the Spring site is the ones that's updating it. Same for Pivotal network. And so you change the whole relationship between the infrastructure and the developer to be something that is developer native.
Interesting. So we just had Cornelia out here in Pittsburgh. I know she's working with you, and the different stories she's talking about with she's in the field and she's doing a lot of this stuff. But I thought it was interesting to see kind of the influence of the old Pivotal labs, like real hardcore Agile XP type of development on this process, and how now, at least this conversation with Cornelia and some of the Pivotal people, they're saying that Cloud Foundry as a solution to kind of this continuous delivery problem just kind of naturally arises when you're trying to minimize the cycle times and all the stuff that you want to do in this sort of lean agile approach, where we want to be able to do deployments and we're doing our tests and we have the CI, and it just seems like a natural thing that you're going to develop this deployment pipeline knowing where we happen to have one, and so then like the whole thing, at least in some of the stories they're telling, is driven by this need to go faster or to support this kind of faster iteration with the development process.
Yeah, I think part of the challenge for me is just, when I'm out talking with customers, and I'm fortunate enough to spend about half my time on the road meeting with kind of like CTO, architect, and a lot of really talented individual contributor folks in enterprises. We primarily talk to the Fortune 500. And part of the thing I have to keep in mind is what it's like for them, because I do live in the world of Pivotal Labs. And it was, to give you an example, it was 3 weeks before we were going to launch the 1.0 of our product. And I decided that we couldn't wait to the 1.1 to ship the update site and the content site for Pivotal Network, where people would go and get updates for their software and see what was available, and interact with, hey, I've downloaded it, but now what are the updates, and how do I sign in and see what I need? And in 3 weeks, we created an agile team. We pushed all the software out to Cloud Foundry hosted on our Pivotal Web Services, and we had it ready to go in time for the launch in 3 weeks out. And there's almost no company that I talk to that could launch a production web service and continue to update it in prod, starting from scratch, the whole process through inception to delivery in 3 weeks that I can think of. I don't know what you've seen, but I don't think that's normal in the enterprise to even start provisioning the infrastructure to do something on, let alone like, yeah, we had it done in 3 weeks, enough to launch with the 1.0. And I have to remember that when I go out, like, that's not what they live with every day, and that's what I'm here to bring them, is like that combination of agile, continuous delivery, and a platform that just works for developers.
So when you tell them stories like that, what are they? I mean, I did some work in the enterprise world, and I came from startup land and agile land, and I was always really frustrated with their relationship with time space, essentially, where things take, 3 months is just so fast for some of them, and
Yeah.
and they're used to project plans that are 18 months out, and often, this was the worst part, is often those projects were almost expected to fail. Instead of trying to iterate from a half solution to a full solution, they have this big game plan that isn't even going to show up on anyone's radar for 18 months, and most people are expecting it to be a disaster already.
Yeah, that's what I talk about. I always say, that what's changed from over a decade ago till now is that it used to be an 18-month project plan, or a 9-month project plan, or a 6-month release, or a 9-month release. And this crazy guy that I've poked some fun at too, and I've not always been a big believer in, Paul Graham, came along and he said, hey, what if I give 4 people this new Amazon cloud thing, and measure them on their progress every week, and I challenge them to grow their adoption every week by changes in the product. And it created this really aggressive, fast moving, high clock speed kind of mentality that I think a lot of the companies that have been disruptive in Silicon Valley and otherwise in the last 5 years have employed. And when you look at Adrian's stuff from Netflix, he talks a lot about taking layers out that slow things down without adding value. But what's happening now is that these companies, the startups, have been so successful that every enterprise has to care about them. And so they're all going, gosh, how do I move faster? And by packaging up all of those things into an iPhone-like experience for them to just deploy and manage software in a simple, unified way, we've gotten a lot of traction in even just 1 quarter being out on the road and available.
Well, that's an interesting point that you bring up, Adrian. Adrian's also been, at least recently, talking quite a bit about this idea of microservices, and there was an interesting exchange with one of the people that is often held up in kind of the DevOps conversations, the SE deployments. It was at a conference, it was like GoDoCon or one of them, I can't remember which one, but there was a microservices presentation from Adrian, and then the Etsy people were showing what they're doing, and there's a back and forth discussion about this kind of monolithic thing versus the microservices thing. And I was kind of looking at what you guys were talking about and how you're thinking about things, but you basically start already with the platform Well, I would actually go back a step. If you are going to do continuous delivery, you're going to build a platform. I said this before. I said this 2 years ago in Silicon Valley Cloud Meetup when Adrian was there and they were having this discussion. Like, you cannot do continuous delivery without the ability to put arbitrary code in arbitrary environments, essentially at will. And then if you're going to go to this microservices world where you're going to do continuous delivery against a bunch of disparate services that have to somehow give you, because there's a critique someone recently wrote about microservices and why it's hard, and a lot of their problems that they're saying are hard for microservices are exactly addressed by these sort of DevOps questions where, yeah, it's hard to deploy all these things. Well, you should probably figure out a standardized way to do that automatically. And if you don't have a platform and you try to do continuous delivery and you try to do microservices, then you're probably going to be in a world of hurt.
I mean, all I can say is preach on, because, like, my biggest area of interest right now, one of my biggest area of interest is the convergence of these platforms, continuous delivery and microservices. So at CF Summit, or a little summit around Cloud Foundry, we have 2 talks on microservices, and I even personally flew a guy named Russ Miles over from England to make sure he could talk about microservices and his work on CF and how those come together. And the reason is that a lot of this gets back to, and I know that you've trolled me a few times on Twitter when I said, oh, a lot of this is about org design. You're like, all of it's about org design. But the
Conway's Law.
Yeah, I mean, it's not even as sophisticated as that. Like, that's like interface design. This, I mean, to some extent, this is even more brute force than that. Is, again, a lot of these people are talking about doing one big monolithic every 6 months, everyone get on the bus, merge, update, or every 9 months. And how do you start enabling teams to deploy and update their own services? And I think in some ways this SOA thing kind of led people down the wrong path, because they thought, well, as long as you express things in the system as web services, then you've done enough. But the problem is that some of those web services are incredibly monolithic, and people struggle with this. So at the back end, there's a web service that tells you everything about a bank user and what's going on with them, but it's an incredibly expensive call to a mainframe system.
So I think this is a personal rant, basically, that we won't go fully into, but where SOA went off the rails is where it basically lost the promise of all the actual service-oriented and just became a way for vendors to sell middleware. Back in when it was kind of the hype of the XML and SOAP and everything's going to change everything, and then it just became another way to do remote method invocation.
Yeah, I mean, there was a promise of all these beautiful recombinant things that would happen once things were expressed as web services, but just slapping a little web service front end on an incredibly expensive mainframe that wasn't performant turns out to be not that optimal, and certainly a mainframe that you can't adjust the logic on, or it's very hard to modify, again, suboptimal. So I think the reason people get excited about microservices is that they could start to build an organization that had, a pizza box team or even a 2-developer team that does a microservice. It's a little bit.
In some ways, I think we're getting all those promises of microservices. We had to go through the pain and get rid of the kind of vendor-driven solutions, right? It's like, oh, well, we're going to sell you this thing that does XML, and then it's going to do. We're going to bake all these committee-driven standards into these SOAP interfaces, and then somehow you're gonna after you sort out this thing that has to compile this thing with a simple thing to then generate the Hillsdale thing, and then it's all going to work. And what we have now is, okay, well, we're just gonna take chunks of JSON, we're just going to throw them back and forth, and we're going to deal with security or whatever, SSL, TLS up in another layer, and it's all going to work out. Like that's giving you most of the promise that was originally the hype that was around the SOA, at least in my opinion.
Yeah, I mean, I think the fact that it's organizationally bottoms up, more bottoms up, like, hey, I created this, you can, subscribe to it or use it if you want, and it's also organizationally bottoms up, like, hey, we're just going to use, JSON, and it's fine, and it's not like
Well,
the
so
CIO.
I can add a field to my JSON blob, and if you don't care about it, you don't have to worry about it. You don't have to go grab my WSDL and like regenerate all your stubs to make the request to my service.
Yeah, and so I think it's much more organizationally correct than the old top-down cathedral style planning of SOA version 1, which I never really believed that much in. I mean, I was interested in it in like 2002, but it quickly got so monolithic. I mean, even in the history of J2EE, and I'm guilty because I was at Sun at the time selling big chunky servers that you deployed every 18 months to run that chunky top-down plan J2E stuff on, and pretty much my whole job right now is to try to take that away and to empower smaller agile teams to move rapidly at their own pace.
This is kind of circling back to one of the points I was trying to make earlier, but don't you think there's a difference between, I mean, if you look at, you say anything that runs on Linux, right? And you look at the different, even ways to do Java, like all these different Java containers, Java web apps, whatever, then like the difference for you to deploy one of those types of containers versus others, you don't think there's any difference in kind of like what's involved and what's complicated and what's even possible, or you guys don't feel that at all?
Yeah, there's people out there that don't like this. They very much like the you can get a guidebook of J2EE and every interface is described a priori for you, and you know exactly what they are, and like here's your guide to making your car that vendors used to sell people, and now you kind of go out on the internet and you Google and you hack and you figure something out, and you create an interface on your own. That's a different world, and I think that's why the polyglot approach was like, hey, if you want to use Node.js, go ahead. If you want to use go ahead. And it's a different kind of middleware that we're selling, 12 years later.
No, I think it's actually there's another thing that came up at one of the open spaces at Pittsburgh, which I know you're from, so
Pittsburgh.
represent the conversation was started around this idea of polyglot. What does it mean to be polyglot, and is it good, is it bad, or whatever? And I think that there's certain aspects of, especially running at a high scale, when you have a proliferation of runtimes, they have to debug, because even with the platform doing all the deployments, there's still going to be something where you have to kind of go into those runtimes and figure out what's going on. But at the sort of the medium end of that scale, being able to have a common pipeline to do deployments across different runtimes without too much trouble really enables those small teams to, especially if you're going to go the DevOps route, and if you run it, then it's your problem, right? Where you're, okay, like we like Node, for whatever reason, or we like Go for whatever reason, and we just, we have our thing. There's a problem with our service. We're the ones getting paged, so we have all the context of what those logs mean. We know that runtime because that's where we live, and we just take care of our service.
Yeah, I think polyglot is a good feature, but it doesn't mean that you should use it. Um, you should use what's right for you and the skills in your team. And when we're writing our system, we try to stick to mostly one language. We were Ruby, we're going to Go now. And so, it's not like everything that comes up, we just have a developer, pick whatever they want. Because there's certainly costs, carrying costs every time you do that. But I think our thesis was that the patterns that we were enabling were generalizable across those different choices. But we're not championing a use 12 languages in your code base and good luck maintaining that approach. I hope no one would misconstrue polyglot in that direction.
So that's an interesting thing too, and that's something that's come up in a lot of the recent DevOps conversations, and there's the conference they just had, and like the tooling around ops and systems work seems to be slowly kind of going towards Go as a language. Maybe not entirely, but definitely there's some movement in that direction. I was just wondering, well, from the vantage point you have, and I know you're not writing Go code, but like, what would you make any comments around, watching the teams that you work with as they kind of go through that transformation?
Sure. I mean, we did a Go rewrite, just as one little point example of the agent that drives all of our deployments called Bosch that I mentioned before. So this got an agent, and I think we saved like 90% or 95%, somewhere in that neighborhood, the amount of memory per agent that was running by moving from Ruby to Go. And then you say, okay, well, at what cost of developer productivity? And a lot of those guys, it was 2 to 4 weeks of of migration time to go from being really great at Ruby to being pretty darn adept at Go. So it wasn't a huge learning curve. And they went faster than that, but I'm just saying it was under a month to switch over the language and to be really productive. So if you get really high performance, good concurrency, low memory overhead, and it's something that you can transition from a language like Ruby to, I think that's why it's picking up a lot of steam.
Yeah, so 90%, that's significant. That's just really the difference between the Ruby runtime and Go.
Let me look exactly. I think it was over 80% memory reduction. And there's a whole series of stats, and don't let me misquote it, but I'll
I mean, it's easy to believe that Go will run that much leaner and that much faster than Ruby, if you know anything about either one.
Yeah, I mean, that's not to say that Go has never had memory problems for us at all, and a lot of the, when we were developing things, I think there's still some debugging that we've had to do along the way as we've written our health manager and some other components in Go. So it's not like, I never want to give people, oh, it's magic silver bullets and all werewolves are now dead, but I think...
Such is the nature of code, right?
Yeah, right, you don't want to oversell it, but at the same time, it's had a lot of benefits and performance for us. It's also, we have our command line was in Ruby, and boy, sometimes if you're not familiar with Ruby, just getting your environment set up can be an overhead. And so a lot of the Java developers would struggle with version management, etc. And just to have a slim little tiny binary that's super fast and Go now just in the command line, that's a big benefit too. So it has a very lightweight installation environment, and that's maybe one area where it's gosh, I'm getting into religious territory, but a little bit ahead of Erlang in that regard.
Just that you can get installed easy?
It's just a quick little binary, just a little execute.
It's a compiled file.
Yeah, that's right.
Well, the Ruby dependency installation show right now is kind of it's interesting to see what direction that will end up going.
Yeah, it's not bad for people who are Rubyists, but when you're trying to do a polyglot paths and you don't want to have everyone be a Rubyist.
I would argue it's pretty bad for Rubyists, if I'm being honest.
Yeah, I not to pick on Ruby, but Go is a big deal.
But I think part of it might be also that the Go doesn't have some of the cruft yet. And it's still, it'll be interesting to see how it evolves, because Ruby was this like exciting kind of space, and there's lots of things you could do, and it's all fun, and now we have all these gems, and now we got to manage them, and we got to have these dependencies. So we're going to build this thing. We're going to bundle them. Oh no, now we're going to have our gems and our RVM gem sets, and pretty soon it's just where we are now. So
I think, just to close on it, the reason Go is exciting is because, gosh, we need it at this moment in like the evolution of internet infrastructure, right? Like, we needed a language that it was expressive, and you could have a senior but not expert level developer take on, and I think it's the right language at the right time, if nothing else.
And then it ends up being basically, it's not interpreted. It doesn't have to go through some whatever interpreter scripting language. It's compiled down to the machine.
Right.
So what else? Is there anything else interesting you that you want to ask me about, or I know you probably haven't debriefed Cornelia from her trip to come see our party.
Yeah, I mean, I think it's pretty cool what you've done in terms of your message around learning organizations and DevOps, and you're also starting to talk a little bit, kind of more in a Google vein around a platform. And thanks for having Cornelia out to DevOps days. And maybe it'd be good to hear a little bit about where you see the convergence of, organizational design and platform, and like those two things kind of converge because, when I used to talk to certain zealots of uh, maybe in one poll that were sort of anti-platform, they're like, well, you can't ever have like a great culture unless you build everything yourself. Like the way that you form a team is you all get together and you go hunt the bear and you kill the bear together and you drag it back to camp, and
You have to drink its blood and eat its
you
heart.
have to drink its blood and you have to war paint yourself and like stomp around, and we did fault tolerance and failover, and we did load balancer configuration. We are warriors now. Um, and I think it's funny to hear your story about how the Google Kai came along and is like, guys, stop doing that. So maybe you could tell me a little bit more about that DevOps day because it sounded pretty rad.
Uh, so so there was a closing. I mean, this is all on the live stream. We can post a link that has the DevOps Days Pittsburgh talks. But the director of site reliability engineering at Google Pittsburgh came and gave a talk, and it was sort of a condensed and DevOps specific version of a talk he gave at Usenix, which is a 90-minute talk. And he basically, the short version, TLDR, is that we should stop building systems that need to be operated. And that to the extent that DevOps reifies this type of operational approach that requires constant futzing with systems, that's bad, and that we should forget about that, and that to the extent that DevOps is about cultures that cooperate with each other towards a common goal and allow people from different backgrounds and different levels of understanding of all these different parts of the system to work together, then we should keep that. So he had one slide which was a bullet list of the babies and the bullet list of the bathwater that he thought you should be.
Separate?
Huh?
You should separate.
Yeah, this is like what he considered like the babies of the DevOps that everyone should embrace. And then his point was, and it was also interesting because we're in Pittsburgh, and Pittsburgh has whatever history with the Industrial Revolution and whatever steel and coal and all this stuff up till now. And he was saying, Pittsburgh is good now or better now because you don't have all the coal in the air, and that's great. But we shouldn't stop. We shouldn't stop getting better. Like we shouldn't sell ourselves short on what's possible and what we could get to. And he was making that analogy about Pittsburgh and also about operations. So while what we're doing now is better, there's this other level that you can get to. And he was kind of saying it in a way that it's like, this is where I live. Like this, I'm at Google, and this is kind of how we do things right now. And you could get to that level too.
I'll just say this, I think it's great they're talking because for too long, I think Google kind of sat on the sidelines hilariously laughing at how the rest of the world tried to do computers. Like, they were doing, like, there's a big thing about containers in 2014 now, and, if you look at the history, Google started contributing that stuff to Linux back in 2006 and 2007. And of course, the whole world's tried to follow their approach to distributed data processing with Hadoop.
Well, I mean, quite frankly, we wouldn't be having any of the container discussion without the code that Google put in the kernel.
That's exactly like it was. It would have been more like the Solaris stuff, where there's all these cool features sitting in Solaris. Solaris x86 was the very first great container environment. With Solaris Zones in 2005.
Back when you worked at Sun?
I used to do that.
So back to the kind of organizational learning stuff, I'm really excited. I've been reading a bunch of this stuff because I have a tutorial I'm supposed to give at Velocity, and so I should probably make it as good as I can. But there's a bunch of, and it's sort of like computer science in the sense that like everything to do with computers was basically done by IBM in the 60s, and then there's all this kind of academic research and oh yeah, key value stores and whatever kind of hashing and this, that, and the other, but the computers weren't very fast, so it's just sort of theoretical, and then it gets tossed around, and then slowly like it gets pulled into the practice, right? So there's all this computer science theory that's not really taken advantage of, or like more slowly taken advantage of than you'd like, and I feel like I kind of stumbled into this thick vein of management theory that people did all this academic research on in the 90s, and then no one really put into practice, or didn't do it in a way that kind of made it be the dominant paradigm. And I feel like when you look at what happens in high-performing teams, if we're talking about digging ditches or building widgets where you have a very repetitive task, then you can start to do things like, okay, we're going to manage this product, or we're going to manage this project with pretty much a waterfall Gantt chart of dependencies. Then that's great, and it might even be optimal. But when you look at the work that is being done right now, software, which is essentially knowledge work, if you try to apply that type of a management structure, that type of a dependency prediction structure, then it ends up being disastrous. And I think if you get to I don't know how much of the punchline I should give away, but I feel like when people talked about the stuff that had to happen to get to like different levels of scale with their architectures, which really have to do with how information is passed through the infrastructure. So if you have the N-tier or 3-tier applications with the databases and middleware and webs, whatever, like the kind of canonical type of structure, then that's really like this centralized store of information, and every request has to go all the way down to that relational database and all the way back up. And when you get into the CAP theorem discussion about the nodes that have the ability to, as a peer, respond to requests without regard to, at least on some level of consensus, depending on how you tuned your consistency, the request, because you're gonna always respond. Like you made that decision that we're gonna always be available. Then it's like the same transition could be applied to people, right? If you have a certain level of confidence and trust and confidence in your organization, then you're empowering the nodes on the edge to make decisions. And I think there's a bunch of interesting research from the academic stuff. There's also some interesting stuff with the military, where when you go to these kind of guerrilla urban style engagements, if you have to wait for the information to go up to central command and back down, like it's way too late. Like you need to be able to decide like at the level of the engagement. I don't know. So I get excited about this stuff. But
It gets me excited too. I'm a big Daniel Pink third drive guy. It kind of sounds similar. Like if you're just having people do mechanical tasks, you can give them traditional organization structures and traditional rewards of carrots and sticks. But if you want intellectual output, you need a lot more purpose, autonomy, and mastery driving them. And that starts, when you want to give people autonomy and that hire people that want to pursue mastery, you start to get into organizational design, right? Because if autonomy is necessary to really motivate people, and it's also necessary in that the node construct you talked about, like where you make decisions not at one central point, I think the convergence of those two is pretty awesome.
Well, and then you start to look at so there's like this whole kind of software's eating the world vein, and we have to go faster, we have to cycle faster. If you're going to make decisions fast about how things should be done, and this also resonates with all the Netflix narratives, right? So whenever you talk to, whenever you hear Adrian, he's always about the OODA loop, which I think should be deconstructed at least one more level, because I don't always think the cycle time on the OODA loop is the best determination of outcome, and that could be its own kind of blog post or talk. But you basically have at least some aspect of speed and the cycles, which is important. And if you're going all the way up to, or you're counting on decisions being made at managers that go up this chain and back down to do that day to day, not to mention the intrinsic motivation that comes from just creating, then you're going to lose. You're going to lose to someone who can capture that inherent motivation and allow those kind of jet fighters, if you will, to fly their planes.
Yeah, I think that's one of the downfalls of, from my standpoint, I've seen it in big companies. I worked at VMware and Sun, where big R&D projects would kick off, and the kind of high poobah of the waterfall plan would be anointed as the person who got to spend that couple $100 million on that project. And what really happens is they write a hype cycle where it's going to be perfect, it's going to be perfect, it's going to be perfect. Oh, then it's not, and then they get fired, and they try somebody else. And I think that's where enterprise comes from, is this ongoing cycle of like 60 or 70% failures on projects, but great hype and anointing of the leaders in the meantime. And I think that's why the more distributed, autonomous node structure of you're talking about could be more effective for just general execution and decision making.
Well, I've seen this even in startups where they feel like, and a lot of them, they kind of inherent mindsets and mentality from these enterprises, and there's some permeability, right, in recycling of the personnel, but it's like this idea that you're going to somehow, with this one key hire, if we just had the person that have the special thing that we don't have right now, if we could just hire them, then that would fix all our problems. And then so they go and they do this search and they try to find that guy or that girl, and then that person comes into these, in many cases, really unrealistic expectations, but then they, to your point, like they kind of have to hype themselves, like as that thing, as that messiah, to like come into that role, and then that just sets up this cycle of disappointment, and then they do it again, right? And like, I don't want to name names, but I think when you look at some of the cloud efforts and especially some of the OpenStack people, they definitely did some of that cycle, and they try to build these grand plan. Here's the thing. So I kind of want to do this talk. So I used to want to do this talk about the Vasa against the Gossamer Condor, where the Condor, like so this story of the, I think his name's Paul McCready or whatever. He's like, he flew across the English Channel.
I don't know the story, dude.
You know it, or you don't?
I don't.
So it's the Gossamer Condor, and so the idea is there's a prize for flying the first human-powered flight across the English Channel. Let me find the story. So there were a bunch of these guys that had been trying to do it, and there's quite a bit of money. So it's Paul McCready's company, AeroVironment. So it was successfully completed in 1979. So they won the Kramer Prize. And so the prize had been set up in, so it was established in 1959, and there were two of them. And the first one was to fly a human-powered flight around a figure eight around two markers half a mile apart, and the second one was to cross the channel from England to France.
Human-powered.
Human-powered. So the first one, so the prize basically stood for 20 years without anyone solving it. And for brevity and for the emphasis, I'll probably butcher a little bit of the story, but basically my understanding is that there are all these teams, from all the best institutes that would go out and they would look at the problem and they would engineer their solution. It's like, okay, well, here's what we have, as a human, and here's like this construction, and they would build this thing, and they would go try to do the flight, and they would crash every time, and then they would take what they had and they would go back to the drawing board and they would say, okay, well, what's this thing look like, how to break, and then they'd have another go at it maybe a year later, right? So there was like this real long feedback cycle and really high-powered engineering going into it, but not making much progress for about 20 years. And the insight that McCready had that kind of reframed this is he sort of said, instead of trying to come up with a way that we can, solve all these problems up front, what I'm going to do is I'm going to optimize for building materials and lightness that I can rebuild the aircraft as fast as possible. So they started building with this gossamer fabric and basically like these thin pipes, and they were able to in some cases they were having a practice flight, crashing in sort of controlled setting, and then rebuilding and maybe going again in a few hours. So they're doing so many more flights.
Agile platform.
Agile. They designed an agile platform where they were able to iterate, and they solved it from the time they started till the end. Is like only a couple years. And so it's really about the cycle time and their reframing of the problem. So if you try to solve all the engineering problems at once, and then you crash, and then you go back and you try to solve them all again at once, and then you crash, it's a bigger or harder problem. Where he like said, okay, well let's solve the problem of being able to rebuild our plane with really cheap materials really fast, and then that solved the Gossamer Condor was able to get past the channel.
That's interesting because the history of flight is full of that. You know, the Wright brothers were up against this anointed institutional leader from the Smithsonian. Have you ever read the history of this?
A little bit.
Yeah, and they were just a couple dudes from Indiana, bicycle mechanics. But this guy had and I forget his name, and it's late here in Minnesota, so I won't look it up, but he tested things by flinging poor unfortunate souls off the top of a big tall boat in the Potomac River in Washington, D.C. like once every couple of years. And the reason the Wright brothers crushed him, and the reason their first flight worked actually, was they invented a little thing called, maybe you've heard of it, the wind tunnel. And the wind tunnel was a way of mocking up the wing shape. And so I always think that the most important thing the Wright brothers invented really wasn't the airplane, but it was the wind tunnel, because that was they invented the machine that makes machines that fly.
So on that note, and maybe this is a good one for another day, have you seen the stuff Kyle Kingsbury's doing? The Jepson, where he's doing the distributed system database analysis with like partitions. He's got like this synthetic, it's like a little DSL for doing.
Yeah, it's essentially the DSL for database anti-marketing.
No, but what it is, like I had this insight the other day, it's a wind tunnel. Like,
yeah, it's a database wind tunnel.
He's building a wind tunnel for distributed systems. And I think, so I always wanted to do this talk doing the Gossamer Condor contrast against the Vasa, which is this Swedish warship that has like every possible mistake you could make in a project.
It failed so fast that it's actually sunk intact right in the harbor. So you go to Stockholm, you can see it.
Well, it was launched after failing a stability test. Was the problem? Like they did this stability test and it failed, and they're like, YOLO, we're going to launch it anyway.
Do this.
Which is like, I've never seen any software projects actually try to do that, ever. No way. No software project has ever failed QA and then gone to production. Just doesn't happen. Anyway, so wind tunnels, Vasa, and Gossamer Condors. We'll talk about that next time.
Yeah, I think that's important, and I think that's why the convergence of platform and organization is so interesting, right? Because it's one thing to have the right attitude, it's another thing to have the right attitude plus a wind tunnel. And if you do those two things together, you're pretty lethal.
Yeah, you can fly.
Right.
It's crazy. Next level.
That's how I got to Minnesota, actually. I didn't walk.
Well, it's late. It's late here in Pittsburgh. It's late in Minnesota, and I'm sure we'll talk again.
Peace out, buddy.
Thanks, James. Cheers.